everybody. It's so good to be here. My name's Jeff. I'm one of the founders of an open source project named Ollama. It's the easiest way to get up and running with large language models locally on your Mac, Windows, or Linux computer. Ollama is especially good at running small models, and I'm going to be talking a bit more about those today. But before jumping into that, just wanted to share a little bit about my own small and local journey. Before working on this open source project named Ollama, I was at Docker for 5 years, where I worked on Docker Desktop, which was a way to run containers locally. And I'd been working on this kind of problem space for a good 5 to 6 years. And it ends up that, even though kind of Docker originated from software that was used in production at Google and cloud computing was its primary purpose, a lot of what makes Docker Docker is actually the local experience around it. And Docker Desktop's used by over 20 million developers today. After Docker, these new models were coming out. You may have heard of them, like Llama or Gemma. And we kind of realized that we weren't AI experts, some of us on the team, but we really kind of wanted to run these models. And there's a lot of problems with running AI models that felt very similar to running these kind of Linux containers. And so I'm here to talk a little bit about these small models and how to run them locally. I'll start off with a little bit of an introduction for those who aren't familiar with these models, and then talk about two primary use cases that the team and I working on Ollama have been seeing very consistently around deploying small models locally. And then we'll talk a bit about how you can get started with small models and what are actual use cases that are being used in companies today around small models. OK, so small models. I'm sure everyone here has probably used ChatGPT or Claude or Gemini or tooling around that, like Perplexity. And the whole idea behind small AI models is really similar to these large AI models that really took the world by storm kind of in 2023 and is obviously continuing to grow really fast today. They have a very similar architecture and core idea. They're based on the same white papers ultimately in research. The differences, though, is that they're really small, whereas these cloud models, although they're not disclosed, probably have hundreds of billions of parameters, they call it, or even trillions of parameters. These small models only have maybe 0.5 to 70 billion parameters. They're only a few gigabytes in size, which means they definitely fit on your laptop. I mean, heck, they even fit on a phone. And they run on ordinary hardware. So you don't really need these really expensive, hard-to-buy clusters of GPUs all wired up in a special way to run them. You can actually run them right here on your existing computer. And I'll show a little bit of that today. The most interesting part about it is similar to like a lot of the most powerful database software is that they're openly available. So they're not gated. You don't have to put your credit card. You can go and download them. A lot of them even have very easy to adopt licenses like MIT or the Apache license. But great that these things exist, the kind of miniature versions of what really started this whole AI wave. But why do they matter? And there's this kind of misconception that small models are kind of just shitty versions of what you can get from OpenAI or Anthropic. And that's really untrue. And so there are kind of three major reasons. The first one is that counterintuitively, even though you're running them on kind of existing consumer hardware, they're actually a lot faster. It's for two really simple reasons. A lot of them are why running a local database is faster. The first one is that you ultimately, with less parameters, the model just runs a lot faster. The compute time for an AI model today that uses the transform architecture, which is what most of them do, is quadratic with the number of parameters. So it's n squared. So just by going from hundreds of billions of parameters to 1 billion parameters, for example, you're cutting a serious amount of compute time. And the second and more interesting use case is that because they're local, there's no round trips. And this shares all the benefits of why small data runs so incredibly fast, is that you don't need to go off to the internet. You can run everything just locally. And so the network's not even part of the equation. It's also the fact that the model runs locally means that you can keep your data to yourself. And this isn't just about kind of the paranoia of sharing your personal data, which is where a lot of the kind of rhetoric is today around data privacy and in these small models, it's actually more about the fact that you're liberated to do whatever you want with the data. And you don't have to worry about security controls and privacy and getting approval to use these models. You can kind of have the freedom to just experiment locally. And the third and most interesting one is just the cost structure around these models. They're not free to run, like they still take compute. You still have to buy your computer. But one section of the Small Data Manifesto that I really loved was the part that talked about modern hardware catching up, and Jordan spoke about it this morning. That's even more true with these AI workloads. Basically, every hardware manufacturer on Earth is changing right now to accelerate AI workloads. And within a year, Intel's supposedly says we're going to have 100 million AI computers out there on the market. Apple, a huge percentage of Apple's silicon, is something like a third, is dedicated to neural processing, which is incredible. It's a huge chunk of the silicon that they produce in every MacBook. And then what's more interesting than the fact that we have all this hardware that make these models incredibly fast locally are just the hidden costs that we don't really talk that much about, but you really face when you're trying to adopt AI models. There's two that are really common, and they were honestly shared in the data world too, and it's why a lot of the most relied upon software and databases, and by no means am I an expert with data and small data even, was the fact that open source software just removes a lot of the hidden costs, right? Like if you want to switch cloud providers, if you want to upgrade your machine, if you want to change the application. There's a lot of cases where relying on something that's openly available just cuts a ton of pain, time, and risk. And that's very true with open models as well. And so whether you're thinking about, I'm not sure where this model is going to run yet, I want to run it in one place locally, I also want to deliver it to a customer environment, you don't have to worry about the hidden costs from switching around, or hey, maybe I have a customer that has a unique environment that wants to deploy differently. You don't have to think about these kind of really hidden costs that aren't really coming with the price tag of the model. You don't really pay per token for that. And so a lot of this is kind of a repeat of the benefits we get from small data. It translates kind of one-to-one to these small AI models quite nicely. And the last one that's kind of an interesting development that wasn't totally expected is just how many of these small models are available. It's really incredible. For the cloud scale AI models, you might have a selection, you can count them on one hand from most companies, how many you can buy or use or try. But there are already thousands of small models available, different specialty sizes. Almost every trillion-dollar company in the world's open sourced a model already, whether it's Apple or you have the Ollama models from Meta and Gemma from Google and Phi from Microsoft Research. Each of these has already been fine-tuned, and for example, NVIDIA's distilled the Llama models into a whole new type of model. So there's been this incredible development of models and a whole ecosystem forming, which you just will not get through, ultimately the cloud scale models. It's kind of one-to-one with a lot of the extensions you might see for Postgres, which make these models extremely versatile and customizable for your use case. Every company knows their customers best. They ultimately want to customize these models for that use case. Open models, by far, are the best way to do that. OK, done preaching about open models, I think. But the most interesting is what are people doing with them. Before that, though, I'd love to show a really quick demo of just what they look like for those who aren't familiar. There are quite a few ways to run these open models. If you're really familiar kind of with machine learning and kind of the Python environments, there's a ton of tooling around that. Ollama was built for everyday developers that may not be comfortable with machine learning tooling. So I'll give a quick demo of what Ollama looks like. And so in this case, let's run the first one that was on that list, Llama 3.1. And this will load it directly here on my Mac, and I can talk with it. So in this case, I'll say hi. And you can see it answers quite quickly. As I mentioned, the smaller the model, this is an 8B model. If we try to run a 2B model, for example, like Gemma 2B, you can see that even by cutting maybe by a third the parameter count, we get quite a speed up in output. And so you're getting speeds that are on par, if not faster, than what you would get with a cloud scale AI provider, all running on your laptop. they're not just good for chatting either, right? So they're not only kind of an alternative to ChatGPT. In fact, that's not really where they shine. Where they're really powerful is when you make them part of your application. So I've got a really simple Python script here that will take the Ollama Python package and just chat with it. For those who have built stuff on OpenAI, this is quite familiar. And so I'll ask Llama 3.1, hey, what's DuckDB? And keep the answer to 2 sentences. And I'll just run that. And within a few lines of code, you can take these small models that are running locally on your Mac or even remotely on a server. You might have a single node server, and you can run these locally. So in that case, uh-oh. Let's do that one more time. I'm going to just restart Ollama really quick. OK, so now we get an output, and it's really fast. And that kind of speaks to the latency point that we were thinking about earlier, which is because it's running locally, you're only really bound by the compute you have. The round trip time for the network is 0, effectively. And these are just 2 of the models, Llama 3.1 and Gemma 2.2b. There's a ton of other models that are available on ollama.com. You can also find them in other model kind of hubs or repositories like Hugging Face, for example, or Kaggle. OK, so that's how you get up and running with a small model, and how you can integrate it with your application and a few lines of code. That's just getting your feet wet. But most usage of these small models we're seeing aren't just really talking with the model. In fact, because the models are so small, they're not great for being a replacement to, say, Google. Whereas the really large cloud models are so big where they actually have quite a bit of factual information. At the size of them, they're able to produce quite true factual information. Small models, that isn't really their strength. Instead, small models work really well when they're combined with existing factual data. Because they're small, they tend to hallucinate, which means that they'll kind of almost try to guess the data or approximate it. But the good news is that when you combine it with small data, you can kind of have the best of both worlds, where you get fast and local models, but you also get factual data that you already have locally. And so how does small data beat small models? The most kind of common approach we see for this is this pretty complicated term called Retrieval Augmented Generation, or RAG, which ultimately has a pretty simple idea, which is instead of just giving a model a simple prompt, augment that prompt with some real data that comes from an existing data source locally. And so at a high level, what this looks like is, what we just showed is kind of the left-hand side of this, which is, hey, I give the model a prompt, and then it gives me back a response. And by augmenting the model with data, you're kind of building up this vector store, this kind of separate data store of snippets of data that the model can use at runtime. And so there's some pre-processing work required a little bit. And there's some incredible tools to use around this, such as Llama Index or LangChain. I'll give a quick demo of that right after this. But effectively, what you can do is compensate for the fact that these models may not know about factual data in the world. They may, and especially even the cloud ones, won't know about your data. So you can provide this data to the model at runtime. And then you get this really great experience where you get the benefits of a model where it's speaking a natural language, it's able to reason about the data, but it also has real factual data that it can use. So I'll give you a quick look of what that looks like. And so switching back to my demo here, in my kind of demo bucket directory here, we have some duck facts. And so a ton of cool facts in here, like, hey, what's the fastest duck ever recorded? Are city ducks different than country ducks? And so let's see how we can talk to this data effectively. And so there's a lot of code in here. This is a Llama index example. But the most important ones is that we're taking the Gemma 2.2b model, and then we're taking this facts.txt file that I just showed, and we're kind of creating this vector store of all these facts that the model can use at runtime. And then by connecting the vector store of data to the model, Gemma 2.2b, we can query the model and then talk to it. And so if we go over to, if we run this RAG example, you can see here it's loading the facts file and then splitting it into 23 different chunks of data. And then now we can talk to it. So how fast do ducks fly? You can see here that it kind of went and grabbed that 100 miles per hour figure and kind of brought it back and say, do ducks dive? Like there was a, and yes, ducks can dive. Okay, well that's not super helpful. But you can say, how high can ducks fly? I found this fact really cool. Ducks can fly up to 21,000 feet, which is pretty much like a commercial airliner. So it's a pretty interesting fact. But as you can see here, you kind of get this the best of both worlds, a small model, snappy responses, but you also get real factual data that the model can use at runtime. So that's a quick example of retrieval augmented generation and kind of what we're seeing as today the most common use case with small models. Next, I want to talk about kind of the new wave of applications that are being built with small models. And the best word I have for this is small agents. And agents, everything's an agent these days. It's a really popular term. But the core idea behind this is some of that stuff I just showed, there's quite a bit of plumbing that needed to be set up to connect the data to the model. And the core idea here is, well, what if the model itself could decide when to go get data and how to go get it? That way you don't have to build all this plumbing. And so this is where tool calling comes in. And it's a really new feature of small models. It was launched in the big cloud models about a year ago. But only in the last few months have we seen the foundation kind of frontier small models support tool calling. And so the idea here is, well, instead of having that plumbing, can the LLM just decide if it needs to go fetch some data from a database and then use that to answer a question? I'll give a quick demo of what that looks like as well. So switching back to my demo here, I have a really small DuckDB database here called ducks.duckdb. And I'm just going to grab some records from that. So I've got a database of ducks. And I'm going to limit it to 10 ducks. OK, so here we've got some ducks. We've got their first name, last name, the color of their feathers. Great. And so how am I supposed to get the model to use this data? So the next example I'll show you is a tool calling example. And again, there's a little bit of plumbing here, but it's generally kind of a set once and forget. What we're going to do is connect to our DuckDB database, and we're going to create a tool using LangChain called the query tool. And all that does is take the query that you want it, that the model decides to write, and it executes it and returns the model the response. So it's extremely simple. And then what we're going to do is tell the model, you're provided this DuckDB schema. We'll give it the schema to help it, and say, here's a query we need help with. We don't even tell it to generate queries or anything. Just answer the question. And then what we'll do is a little bit of code to make sure that if the model needs to run a function, we'll do it on their behalf. The model isn't kind of sentient. It can't go and just start running stuff on my computer. But it can elect to run one function at least. Great. So let's go ahead and run that now. And what that'll do is run this new model that came out last week called Qwen 2.5, which is a new kind of frontier open source model by Alibaba. And a section of their models have, cross-section have a quite permissive license as well, so they're really easy to get up and running and kind of don't have much to lose. But what's cool about these models is they're both small and really good at tool calling. What's even more interesting about this model, Qwen 2.5 Coder, is that's really good at code. And so let's say, what color is Marty McFly? And so we'll prompt that. Oops. Wow. OK, so here we've got and I will preface that tool calling is a pretty new feature of these models. So there's a little bit of work required to get them to really click. But once they do, they tend to do it quite reliably. And so here we have, for example, the that the model decided to write, which was, hey, go select the color where the first name is Marty and the last name is McFly. So it was able to split the name into two, understand that we're fetching the color column, and then it's able to fetch a record. We can ask how many ducks are yellow. And here you can see that it went in and it did an aggregation query to go and figure out how many ducks are yellow. So it's writing all these queries, and we're just executing on its behalf, and it's able to go fetch this data. And then once it fetches the data, it's able to interpret the response in the context of the original prompt. And so here it got the number 8 back. It combined the two, and it said, OK, well, here's the prompt. Here's the output from the tool. Now we can answer the final response, which is there are 8 ducks, yellow ducks in the database. And this is just the start. Reading data is only the beginning. These small models could also write the code to edit data. And so how do you get started? So this is just some examples, some coding examples of what you can do. But I want to talk a tiny bit to wrap things up about how people are using these today. The first use case is really, and the one we see the most common, is don't go start with something that's customer facing, where a customer needs to talk to a model. That's kind of what people jump to. But in reality, what we're seeing is these internal tooling, this back office stuff that's boring, not really customer facing, and it's stuff you don't really want to spend that much time on anyways within your team. And so things like IT help desk, or boring security questionnaires, or data engineering and reporting, and not the fun parts of this, but the parts where you're actually just doing kind of regular requests internally, for example, versus actually going and innovating on how you're querying data and storing it. And lastly, the most kind of common one we're seeing by far is just engineering teams using it to become more productive internally, so they could focus on new features and not on managing issues or code review. Small models also, it's not a choice of whether to use small or big. They actually work really well together. And this kind of is similar to the hot and kind of cold data analogy, where if you really need a big model, you can resort to that if you have to. But for a lot of queries, you can just use small models. And they actually work really well in tandem. And this is already what Apple and Microsoft Copilot are doing with their own small and big model stacks. And most importantly, it's never been a better time to start small. Open source models are rapidly catching up to these cloud scale models. This is kind of a hard to read graph, but as you can see, the lines are converging. And while a lot of the best open source models are very big as well, the small models tend to be growing at the same speed in terms of performance and benchmark results. And so it's only a matter of time before these small models aren't just small, but really mighty as well. Thank you so much for having me. I'm so excited to see what everyone builds with small models. Here are some of the tools that were used in the demos, as well as some information about myself and Ollama. It's never been a better time to start with small models. I'm just so excited to see what everyone builds. Thank you so much.